In today's video, here is a nice problem is coming from Brazilian Mathematics Olympiad edition 1997. Here is the following statement. Determine all these pairs x, y, p, q as a positive integers. So p, q are primes with x and y are integers, positive integers. So we get this condition, x is strictly superior to number 1. So we get the difference of these primes with the exponent x equals to the power of 2 to the y. Okay, so without any argument or argue, it's clearly these primes are odd primes because we have a difference equals to the power of 2. Okay, in fact this is very nice and interesting equation. Hopefully everybody is excited to work on this one. So now I would be recommend to give the hand to this problem prayer against full solution. Go ahead, pause this video when you come back to see the full solution. By the way, don't forget to hit the subscribe button, support the channel, like, comments, and subscribe. Now let's jump into the solution. Even though the structure of this equation is very nice because you have a difference of two primes with the same exponent equals the power of 2. So this is nice thing. But not nice thing, we have 4 unknown variables. We have x, p, q, and y. Now let's get started with the first step. We are going to break this one into two cases. We are going through the parity of x. Assuming x is odd, we are going to see what is it going to give us. Then also we are going to assume x is even to see what is status of this equation. So first of all, let's start with x. If x is odd, which means it's clearly x is superior to 3. If x is odd, we are permitted to transfer this one into the product as a factorization. So we get here the following. We get p minus q factor p to the x minus 1 plus q is multiplied by p to the x minus 2, and keep with this one all the way down until you get the last term with x minus 1. So this one is clearly equals power of 2 to the y. So it's clearly this one is even because p is odd, q is odd. So the nice thing here that this product is given as a power of 2. And keep in mind also this bunch of these terms all are odd. Because since we get the exponent is odd here in this one, so we have odd terms here. So which means this is odd. Okay. If this one is odd, this one is even. So the whole power of the whole evenness is going towards number 2 as a power. But this one is going towards number 1 because nothing to replace here with the odd factor here. So the only odd factor that we have number 1. So which means this the whole thing equals number 1. If this one is equals number 1, which means the exponent x minus 1 equals 0. Okay. If x minus 1 equals 0, which means x equals 1, it's clearly it's impossible because we get x is superior to 3. Which means on odd exponent we have no solutions. So which means the only solution that we can get when we have x is even. Now let's get rid of this one and move on to the next case when we have x is even. Now if x is even, we are simply going to set x equals to m because x is even. Let's replace this value of x into this exponent and factor out this one on the form of the product. I will get the following. I get p to the 2m minus q to the 2m. By factoring this one out, by factorizing this one on the form of the product, I get p minus q, p to the m minus q to the m, factor p to the m plus q to the m. The whole thing equals a power of 2 to the y. Okay, it's more simple here. Since we get the right answer of this equation is a power of 2, which means each of these terms must be a power of 2. Okay, so let's put this one on the form of the equation system. So I get here p to the m minus q to the m, which equals 2 to the I, and p to the m plus q to the m equals 2 to the j, where is j is strictly superior than I. We are not going to sum these two equations. I'm going to make the difference. Okay, so I'm going to put this equation minus this equation. So it's give me the following. This one will be cancelled out. I will be left with 2 times q to the m, which equals 2 to the j minus 2 to the I. Now let's factor this one out. By taking 2 to the I as a common factor, I get 2 to the j minus I minus number 1, like this. Then I have number 2 here. I get number 2 here. I'm going to divide both sides by number 2 by keeping always I is super equal to 1. Okay. Now we are going to divide both sides of this equation by number 2. So I get q to the m, which equals 2 to the I minus number 1, factor 2 to the j minus I minus number 1. So I have this nice equation here. So it's more clear. We know q is an odd prime, cannot be equal to this one because this one is even. So equals to this one, which means the exponent of this one must be 0. Okay. So let's replace this exponent with 0. In the other word, if we get I minus 1 equals 0, which means I equals 1. So I get I equals 1, which means I get p to the m minus q to the m, which equals 2. Okay. So I'm going to take this one on the side here because I'm going to need it at the end. And also q to the m equals to this one, which is 2 to the j. By replacing I with number 1, because we already calculated that, I get this one. So we have ended with this nice expression. So I have ended with this nice equation. So I have 2 equations. I have this one and this one. I'm going to replace q to the m with this one and find p to the m. So I get p to the m equals 2 to the j minus 1 plus number 1. So I have extracted 2 nice equations. Okay. Now let's take this both found facts at the top and continue solving this equation. I previously found 2 similar equations. One of has a minus sign, the other one has a plus sign, but we still have a problem here. So the exponent is still unknown. Okay, here we need to know the parity of j in order to solve this equation. So we are going to go through 2 cases. If j minus number 1 is odd, so I'm going to reduce both of the equation to the mod 3. Okay. So I get the following. By reducing the first equation, I get q to the m is a congruent to minus 1. All is raised to the j minus number 1 as an exponent minus number 1. It's clearly, since we get j minus number 1 as an odd exponent, which means this minus 1 in turn turns into minus 1. With this minus 1 becomes minus 2. Minus 1 becomes minus 2. Then adding number 3 here is going to give us number 1 mod 3. Okay. This one is telling us, since we get number 1 as a remainder, which means 3 not divides q to the m, thus 3 not divides q. So we have ended with this nice fact. So let's do the same thing, but let's do the same thing on the second equation by reducing this one to mod 3. So we get the following. I get p to the m is a congruent to minus 1 to the j minus number 1 plus number 1. The similarly is given to give us number 1 plus minus number 1 plus number 1, which is a congruent to 0 mod 3. Okay. So since we get 0 as a remainder, this one is arithmetically telling us 3 divides p to the m. In the other word, 3 divides p. So I have 2 nice facts here. I get 3 divides p. At the same time, I have 3 not divides q. Okay. So 3 divides q. That's mean p is going to take 3 because p is an odd. Since we have this fraction involving prime and 3, we have no choice except we have p must be equals to 3. Okay. So if p equals to 3 and 3 not divides q, but keep in mind here we have p is strictly superior than q. Okay. We get p equals 3 here. So what about q? If p equals 3, then p is bigger than q. Okay, which means p must be equals 1. it's impossible because Q is a prime, okay? Which means no solutions on oddness. No solution odd, which means G minus number 1 is an even. Now let's get rid of this one and work on evenness. If G minus number 1 is an even, I'm going to put it on this form. G minus number 1 equals 2k. Let's take this value of 2k and insert it back into this equation and make it on the form of the product, because we have a difference of the squares. We cannot use this equation because when this one becomes even in the exponent with this plus sign, this becomes non-factorable polynomial. We cannot use this equation, which means we are going to use this equation because due to this minus sign, okay? So I'm going to do this one right away by replacing 2k in this one. I will have q to the m equals 2 to the k minus 1 factor 2 to the k plus number 1. So it's more simple here because we get a product here equals the power of q, which means each of these terms must be a power of q, okay? So let's do this one on the form of the equation system as I have previously done. We get 2 to the k minus number 1, which equals q to the a. The other one, I will have 2 to the k plus number 1, which equals q to the b. Always we keep b strictly superior than a. So it's more simple here. I'm going to get rid of 2 to the k. Since we have known value number 1, I'm going to put this equation. I'm going to put this equation minus this equation. I will have the following. I get number 2, which equals q to the b minus q to the a. Taking q to the a as a common factor, I get q to the a, q to the b minus a minus number 1. So I have ended with this nice expression. So it's more clear. This number 2 is going to take this one because this one is an even. This one it's arithmetically is odd. It cannot be anything except number 1, which in the other word the exponent a must be 0. So if the exponent a equals 0, which means this term must be equals 1. If this one equals 1, which means 2 to the k equals 2. In the other word, k equals 1. It's more simple, okay? Then take this advantage of k equals 1 and insert it back into this one, because I get the value of k, which means I get g minus number 1 equals 2. If g minus number 1 equals 2, which means g equals 3, after we take minus number 1 to the right side. If g equals 3, which means we are going to insert it in either equation to find p and q. So let's do that. For this equation, get q to the m, g equals 3 minus 1, g equals 3 minus number 1 equals 2, 2 to the 2, which is 4, 4 minus 1, which is 3. In the other word, q equals 3 because m must be equals 1. So let's work on this equation. So it's more clear here. P to the m equals the same thing here. I got 4 plus number 1 equals 5. Let's take this m. I get p equals 5. So it's more clear. I get both values, q equals 3 and p equals 5. It's more simple here if you go back to this equation. So you get number 2 here. If you calculate this difference, you get 5 minus 3, which is 2. By taking this exponent as a number 1. Okay, now we have determined the values of p and q. We need just x and y. It's more simple here. It's more simple here to determine x and y because we know the value p and q. So since we know m also equals 1, let's replace m with its value here. So I get 2 is multiplied by 1, which equals 2. We know x equals 2. I'm going to replace it here in the origin equation. I get p equals 5 to the x, which is equals 2, minus 3 to the 2. It's more simple here. This is giving us 25 minus 9, which is 16. 16 is the same as 2 to the 4th. It's clearly we determined the solution for this equation. So we get here. So we get p x equals 2, y equals 4, and p equals 5 with q equals 3. Okay, so we found only one pair of the solution for this equation. So I have done this problem. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.